Well, greetings and salutations, everybody. Oh, this was kind of a spontaneous little thing. Usually I have a little bit of time this time of evening on Fridays, and I just happened to have gotten this comment from Riley. Was talking about doing the model a little bit differently that we did the other night, and okay, I'm open to hear what he's got to say. The but it's kind of funny. I love it when they throw it in here. What do you call it? If you refuse, that's okay. But I will tell the audience that the only reason why you could be refusing is because you don't want to show us what happens when you model it with the angle locked from the observer. Alicia, I just wanted to point out, I did a video. There's about 3 videos back now called Silent Movie, whatever it was, the most recent one, and I gave everybody the ability, well, not the ability. I didn't give them the ability. Um, I pointed out where the software is that you can do this yourself. Okay, there is a watered down version of 3ds Max. It's called G Max. It is no longer from the available from the manufacturer, in this case Autodesk, but a 3D modeling uh, website called Turbo Squid actually has it available for download. All you have to do is make an account with them, and then you can get a key for it. So yeah, so that's what that is. But so my question is, why come to me with this? I have actually given you the tools to success, and you can do it all by yourself. And come up with whatever wacky conclusions you want to. But nevertheless, this was the post that I got, and I offered to Riley that I was going to be here at 8:30 UTC. And yes, Autodesk is definitely part of the conspiracy. And so I said, all right, well, let's uh, I said I'm going to have a live hangout. You can join me on there and tell me what you got. Well, he said he was cool with that. As a matter of fact, let me go ahead and find. Here it is. Okay, and he said that he was cool with that. He gave me an email address to send him the link. I don't see him in the chat though, so I'll save sending him the link until he shows up in the chat. But he says, what do you call it? He says that he should be around. He says I should be about, and then gave me an email address that he uses only for his flat earth stuff. I gave him the opportunity to remove it, after I copied it, but that's on him. And but nevertheless, so oh, there he is. Cool. All right. So let me go ahead and send him an email, and then we'll see what the man has to say. And then I get the link. Invite people. That copy. And that. All right, and enter. And let's see here. What? Why is it? Don't show those. Move. Thank you. All right. Nah, Yahoo Mail likes to do kind of smart stuff when you put links in there. All right, so it is on its way to you per the email address that you gave me. Close that. All right, and we'll see what we got. Waiting on Riley. And figure while we're waiting, I'll put this over here. And since pretty much everything is here. Yes, I hear you. Riley.
Yo.
Okay. So, what are we doing?
So you've already done the modeling, right?
Well, yeah, but you say you're basically claiming my model's wrong, so we're going to start fresh.
No, I'm not saying your model's wrong. I'm not challenging your model. Just confirm that you've used the figures that were given on the video, right? Nothing's changed. It's the same way that he's claimed it, yeah?
this is right here. Hold on. I'll wait for it to load. Okay, this is the model that we were working with the other day. And let's see. I was moving something there. I don't remember what we were doing at the end, but I was trying to see something there. But here's the flat model. Here's the curved model. This is the bulge. The side peak that they're calling it. This is the top of St. Helens, and this is the top of Mount Rainier. And per distance, and both models are the same. Just one's bent, one's not.
Yeah. The only thing I want to know, and it'll probably be short this hangout because it should be dead easy work to tell me the answer if you can. What is the angle? Can you see that you've got the angle looking up on both models of the observer?
Yeah, I have the camera pointed at the top of Rainier.
Yeah. What is the difference in the angle from the camera to Rainier on both models?
The difference in the angle to the tips to the tops of the mountains.
So just forget the first one, the Rainier in the background. Okay. You see that you've got the line of sight that goes straight to the top of the mountain on both models.
Well, this is just the camera angle.
Yeah, what is the difference in the angle on the top model to the bottom model?
From the observer's exact height?
Yeah.
All right, hold on a second. And get a tape. So, what I did now, do you agree? Oops, wait a minute. Okay, I have put that to be right exactly where the camera is. Okay, you see that?
Yeah.
Okay. Now this here is just the target. I can move it around at will.
Sure.
Now, you want it on the curved model or the flat model?
I want to know them both. I want to compare the angle to both of them.
Okay.
Because it's tricky when you're trying to. I haven't got a way to model it, and I don't understand how to do it. And I know you said
I've given out the thing, and if you need a class, I can gladly give it to you. Now you want it at the top of St. Helens or top of Rainier?
The one at the back, Rainier.
I know it's actually French, it's like Rainier or some shit like that, but whatever.
Yeah, it's a bit of a
Rainier. All right, so I got it right here to the tippy tip right here.
And what angle does that say?
Okay, that is. Oops. Go over to here and select the base. There. That is, let's see, 0.569 degrees above eye level.
So forgive me, is this on the flat model or on the ball?
This is on the ball model.
So it's 0. What?
0.569. You can actually put all these numbers in there if you wanted to.
No, 569 is fine. And what's the same measurement for the flat one?
Let's do one for the flat one. Hold on. So again, right from the camera. Now, mind you, that's degrees above eye level. Is that what you were looking for?
Yeah, above the eye level, yeah.
Okay. Yeah, it's kind of funky how it does this. It actually flips at 180 and it goes back down again. All right, so on the flat model, try to get it exact here. On the flat model, it is, let's see, 1.323 degrees above eye level.
Now, do you agree that's significantly different, right? It's not similar.
Of course not. It's not.
So let's just do the maths and working out the difference between the two values. Just hang on. So we got 1.323 minus 0.569, 0.754. Can we just agree that that's the difference between the two? 0.754. Right, now what I want you to do, if you don't mind, do me a triangle, like move it like further down the page or whatever.
Oh.
What I want to know, what I'm trying to work out is the difference in the actual height. So use the distance to the same distance, the same length. So hang on a sec, I'll get you the number. Oh fuck, sorry.
You got to turn down Soundly stuff there.
What we're thinking of here, it's Baldy cats, isn't it? Hang on. I get that value that he, for the Renier thing. Hang on.
Hello and welcome to Baldy.
Oops. It's not that one. It's that one. All right. If you don't mind, would you mind doing us a triangle? Put a fresh triangle on, and the base of it is the Ranier distance on the flat plane, being 167,371 miles.
So you're looking for a right triangle then?
Yeah.
Okay. So let's see. You want. Now, if you want, I could do this in protractor style. It's easier, but.
Well, what I'm trying to work, the bit I'm trying to get from you, if you don't mind, is the height in meters between the differential.
Between the differential.
Yeah, we've got. I want the height in meters and the angular size height. It should be the angular size should be 0.754.
Here's all the heights converted to meters, heights and distances.
No, of what we've just done, then that calculation then gave us a differential of 0.754 degrees. What I want to do, I want to know what that relates to in meters.
Oh, well, shit. Easy enough. Put this down the level and then just measure the difference. I'm just going to do it like this. And we'll do a rectangle. Now, would you agree that that is the center of the icon for the camera? This top line here.
I'm not sure. Maybe I'm not sure if I'm honest. I'm kind of trusting that you'll do it the way.
Well, it's actually just like about 1 meter below it. But hold on a second. Okay, the blue line that goes across here, that goes to the end here, and that's the center of it.
Yeah.
What I'm going to do is I'm going to put this line that I'm working with right now right there. Okay. Now it's right on it, and then we'll just increase the width. Just to get a straight line. That's all I'm doing. I'm using a box to get a straight line.
Sure.
So here's the straight line on the flat model, and I'm going to just move it down, make a copy of it, and line it up with the camera on the curve model as well, just to save us some time. Okay, so that's right there in the middle of it. Okay, now you're looking at you want to know the height from that line to the top of the mountain, correct?
I want to know what over that distance, I want to know what height in meters an angle of 0.754 degrees gives you. Because that's the differential between the two models, right?
Oh, you want to know what the height of the difference is?
Yeah.
Well, here, here, you can do the easy subtraction this way. Watch. Let's see. Tape. I'm going to do it from that line that I just stretched out from the camera to top here. That's going to make a right triangle out of it.
Yeah, that's okay.
And make sure that we're dead on here. There. Okay. Now, the height in meters. Yeah, it's actually kind of silly to do it on the flat one because the height in meters is going to be basically the observer height minus the height of the mountain. But the height in meters on this one is 3,867 on the flat model.
Well, hang on. Let's just check we're doing the same thing. Is the angle of the triangle that you've just, the angle where the lens is at the other end, is that angle 0.754?
That's the angle. That's this angle that we just did.
Yeah, but where's the bottom of that 0.754 go? Is that
right here, this yellow line?
Yeah, that's not what I mean. Right, what we've just done is we've got the angle in degrees for the ball for the top of Ranier, and we've got the angle in degrees for flat for the top of Ranier.
Right.
And the differential between the difference between the two of them.
Right. I'm about to give you that. Hold on.
Okay.
So write down this number first. It is 3,867.
3,867. Yeah.
Meters. Okay. That's the flat one. I'm just giving you the differential in meters now that you can just subtract. That's all. And then, let's see here. Now, I need to put the right angle on it, so it's like that. Because it is actually leaning back by about a little over a degree.
Yeah.
So I did a straight up line. Is that cool with you?
Yeah, yeah, it's negligible, isn't it?
Well, pretty much. But I mean, in the math of doing a right triangle, it's actually worth something. Let's make sure it's straight. Okay, that's straight. So subtract this from that other number. This one is 1,669.
1669. So
Subtract the two.
yeah, yeah, one sec. So 3,867 less 1,669.
People are saying my mic is too low. Hold on.
Yeah, you are a bit quiet, yeah.
Okay.
2198. Right, so what I want you to just confirm now, I think I know what you've just done, and I think just so that we're on the same page. The difference between the two angles for Ranier on the ball and on the flat gives us an angle of 0.754 degrees. And when you convert that back to meters, it's 2198 meters. Is that right?
Sounds about right. You want to do one at 219 or one triangle completely independent of this to get that?
Yeah, that's what I was hoping you'd do, just to confirm that value is accurate.
Okay, because it can be a little bit fun. All right, hold on a second here.
Are you still there?
I'm here.
You're making crackling noises.
Yeah, no, I was. This thing has a volume increase that I can do on the fucking on the microphone itself, and it wasn't doing what I was hoping it was going to. Right.
Okay.
So let's see here. So we want to go like this. Okay, so I'm just making this yellow so it's noticeable because everything else here is white. Okay.
Sure.
And now the degrees tape. The degrees that we're looking for exactly how much?
0.754.
Okay, now watch over on the left side there where it says XY plane.
Yeah.
Let's see if I can get this as close as I can. 0.5. Oh, 757, close enough?
7.5. Well, can you zoom in and make it accurate?
Oh, wait, 0.754.
Yeah, 0.754.
Yeah. Well, the problem is I can't zoom it in and make it, what do you call it? And make it live at the same time.
Okay. Well, just get it as close as you can, because as long as that value is like near 2198.
Here's what I'm going to do. Watch this. I'm going to split the screen. Try to get this on there as perfect as it's supposed to be. And this is the guy I'm looking for. Because I'm gonna have to constantly switch back and forth just to find out where it's at. Because it doesn't go live once you've let go of it. As in,
Right, I get you.
A live report. All right, so let's see. 6.7. You said 754, right?
Yeah.
0.754.
Yeah.
0.7. 729. 748. 755. Oh, I'm just a little bit too high. Down a little bit. 753. Okay, well, 0.755. Is that close enough?
Yeah, yeah. Okay. So what is the height on that now then?
Now, you're talking about the height at distance, correct?
Correct.
Okay, so what was my distance here? Hold on. Distance to Rainier's Peak is 167,372. So 167.372. Bam. That'll send that out. Split screen back off. Now, this is out to here. And then you want to know the length or the height at this juncture in meters, right?
Sure. It should be about 2198.
I have, well, actually, I might be a little off there. Yeah, I'm a little off the line. I'm also a little short. Good. There at the one. So I have, yes, 2,201.
Yeah, that's close enough. Right, that's the first thing that I wanted to check, because it gets trippy when you haven't got when you can't do what you can do. It gets trippy when you try and look at where it should be on a ball. So it's all right to work out where Ranier should be on a flat plane, but when it's on a ball and you have to do that in perspective view, it's not that easy when you can't model it the way you can. Now, what is your position now with regards to arguing this? Are you prepared to argue this by proxy, or are you just representing the maths?
Well, I find it, first let me say, I find it interesting that you are actually interested in the maths, because I seem to recall you saying a couple of times that math does not represent reality.
Sure. What I mean is, like, I don't mind like this being the end of it, because I've got what I needed. It gives me the basis that I can play with in a bit. But what I'm asking is, are you prepared to argue this by proxy? Because what we're about to do is not necessarily your argument, but I understand if you don't want to do it. That's what I'm saying.
I got no problems doing stuff here. Hold on a second. Now, I keep getting people telling me my mic is low. Hold on. Let me fix this.
It is low. It needs about 40% more.
Oh, I hate this new setup. I got 1803 now, so
1803.
yeah,
What's that?
the update for Windows.
Oh, mine's just done it now.
Yeah, and I mean it's great. I mean it works, but hold on. Shit. Hello. Set up microphone. Oops. Speech. What? Why the hell you give me the fucking speech thing? Hey, why is it still doing that? No, I don't want to make it for speech recognition. Damn it. Volume mixer. Where's like recording devices? Bastards.
Yeah, it sounds, isn't it?
No, they've changed it.
Well, if you go into open sound settings, you can change your microphone volume in there.
Well, that's what I'm saying. It's they changed it. It used to open up, playback devices, recording devices, and all that, and now it doesn't. Hold on. Sorry, this is taking a second. Let's see here. Settings. Phone. Save. Ah, here we go. Oh wait, no, that's playback. That's not input. Output. How's that now?
It sounds okay. I'll let you know in a sec.
Is that a little better? Is everybody?
Oh yeah, it is. It is better. It is better.
Okay, so that's where I do it. Okay, I can do it in Hangouts then. All right. So now, what were we doing? I'm sorry.
It's okay. I was just asking, are you prepared to argue anything by proxy, or would you rather not because it's not your argument?
Well, reality doesn't care who argues it.
No, but the truth does, right?
Truth is subjective. Reality isn't.
Nah, truth's objective.
No, it's not. But anyway,
Beliefs are subjective. Truth is not is
yeah.
not subjective. It's objective, right? The only thing I want to know is, will you agree? Well, you have to agree that the modelling that you've done there is without any atmosphere whatsoever. Are you able to show what happens in an atmosphere?
No, actually, I'm not.
Okay. I've had it modelled. The problem, right? I've had it modelled on both.
Well, please understand. Last time you brought me a model, it was a fraud, and it wasn't even by the person you said it was, or it was by the person you said it was, but not of what you said it was. So,
What are you on about?
The turbines, remember?
Vaguely. What was it? No, it doesn't matter. Forget it. It's all right. Well, right. All right. Let me finish this. Don't interrupt me on this. I've had it modelled on both models, but I've had it modelled with and without refraction. But the problem is the refraction is because, like on Walter Bisland's calculator, for example, you can flick the slider switches up as far left or as far right as you want, and basically it toggles between the two. You can get it really extreme ball, you can get it less ball, you can get it flat, you can get it concaved. So it doesn't really help us in the sense of the refraction is that variable. It's difficult to kind of simulate, but I've been able to simulate it with some parameters based on, like assuming that the temperature at sea level was roughly one figure and then calculating the density shift as you gain in elevation.
Okay, you do realize that nobody here is at sea level.
Yeah, I know that. I understand that. But what I'm getting at is this isn't with an atmosphere, and we both know that stuff that's in the atmosphere, when you look in this like level of distance, this length, it gets a bit trippy because the variables, you only need like a micro adjustment at the camera end, and it makes a big difference the other end because of the distance. Can you agree that?
I'm waiting for you to make a point, man.
Well, all I'm saying is that if we know that we have a pressure gradient, right, a density gradient of the Earth.
Oh, so you're down with the pressure gradient and gravity and all that now?
Well, I'm just arguing it from your perspective, right? I mean, from our perspective, you can't have this pressure gradient without having some kind of container.
Okay, but if you're going to argue it and use it as a support to your side, then you actually agree with its existence.
Oh, right. So we're not allowed to argue moot points, then, are we not?
No. I'm just clarifying. That's all. Because
well, all right. Well, I don't agree, but anyway, right. What I'm getting at is, I understand your model states that there's a pressure gradient because of gravity, right? And a density gradient because of gravity, because all the denser areas at the bottom, the less dense areas at the top. I understand that, and I'm applying that concept, that principle, right? Because the elevation height of the observer is at 327 meters compared to 4,392 meters at Ranier, and demonstrated by the fact that you've angled your camera up to see the peaks of Ranier. Conversely, from Ranier's point of view, imagine you're the light ray that's bounced off the mountain and that's coming into your eye. So the light's coming into the camera lens. We can agree that, or do we agree that the light, that the atmosphere that the light ray is traveling through is gradually getting more and more dense?
Yeah, I'll give you that.
And we both agree that that's going to cause the light to bend towards the normal, or bend down from the light, from the perspective of the light ray.
Define bend down.
Towards the norm, the normal.
So in other words, from the peak of Rainier, it's actually going to be bending a little bit downwards to get to me.
Sure.
Yeah, it would follow the pressure gradient. Yes.
Yes. So on that basis, we can both agree at this point that the light is going to bend down a little bit. The effect from the observer's point of view is that it's going to push Ranier down lower than what it would appear if there was no atmosphere. Correct?
If that but the thing that you're explaining here is following a pressure gradient around a curve.
That's what I was getting to. So
because the experience that you would have across a plane is actually different.
Yeah, it's less curved.
Well, yeah, I'd give you that. Far less curved, almost not. But,
sure. Okay. So this is where I'm at now. I'm at the point where it's quantifying what the effect of the bending of light over this distance actually is. because we both agree that it's going through a less dense medium to a more dense medium from Ranier to the observer.
Well,
It's
a less dense portion to a higher dense portion of the same medium.
Sure, but nonetheless, it is going to have an effect, a small microscopic change to the angle each time it passes through a moisture, though. It's going to effectively bend down a little bit. Agreed?
Yeah, a very little bit in this particular circumstance.
Well, how little is little? That's the question. How would we model it?
I'm not that awesome with the math on that, man. But I do know that as you get higher up, this is why I was pointed out to you that we're not at sea level here.
No, I understand, but we are.
This is also why. Hold on, no, I let you talk. Hold on. And this is also why I pointed out that it's obvious that we're not doing this over water, where that would be a much more intensified effect. Do you agree?
Well, yeah, but we are doing it over 4,000 meters worth of variance, which is going to be effectively like doing it over water, because the difference between 400 meters and a few feet over water,
right? But but basically, as you look up, right? As you look up at St. Helens, or as you look up at Rainier, you're actually looking up out of that to the less dense air, as opposed to looking, let's say, across water or something like that at eye level. Right?
Sure, but on your model, the light comes from the mountain to the eye, right? It doesn't go from the eye to the mountain.
Yeah, of course.
So it's going to bend down as it goes into the more dense medium, right?
Well, yeah, it shoots out in all directions, but yeah.
Yeah, the light ray that hits your eyeball that is processed by the photoreceptor in the back of the eye, them rays that hit your eye are being bent down. From the perspective of the observer, it would cause the mountain in the background to appear lower than what it should be, right?
I would say a very little bit, but sure.
Well, that's the question. How much?
How much? Bit meaning probably about this pixel here.
Pixel? You reckon there's a pixel difference between the refraction?
I don't know. I'm just shooting from the hip on that, but I know it would be very light.
Well, Rumpus reckons that you can.
I don't care what Rumpus says.
I know, but do you remember when you was asking?
No, you're not going to pit me against other people, man. Rumpus has his opinions on things, and
I'm going to pit you against my own work. Do you remember when you challenged me to go back to St. Bees and get it from the beach, and I did, and then you kicked me from the last hangout?
Well, yeah, because you tried to use a Mirage as a measure.
Yeah, I know. But my point is that Rumpus has got to bend light an awful lot in the name of refraction to explain that. But if you're suggesting that over 100...
Actually, awful lot is actually relative here. Hold on a second. Let me tell you something about awful lot.
Hang on. This is what I'm going to say. In my case, it's 700 feet over 30 miles, right? And he's got to bend it to account for 700 feet over 30 miles. But over 104 miles, how much light is Rumpus going to claim could be bent round? Because if it's 700 feet at 30 miles on his maths, then it's going to be more than a pixel over 104 miles, right? According to Rumpus, at least.
Well, like I said, I don't know if you're taking Rumpus out of context or not, so I'm not going to answer anything that Rumpus might have said. Do you understand? Well,
yeah, but
do you get that?
Yeah, but do you understand that you challenged me to go back to the beach and get that land from the beach, and I did, and then you completely kicked me from the hangout saying it was a mirage? Now,
yeah, because
regardless of whether it's a mirage or not, Rumpus is working on the concept that it's actually not a mirage, and he's bending the light around the curve of the Earth to the 700 feet.
Like I said, I am not going to respond to any claims that he may or may not have made. No. Right. That's no. Riley, listen to me, man. Listen to me.
I'm not playing
what you're looking for is you're looking for a soundbite that says Sly said you're wrong.
No, I'm not.
No, stop.
I'm not.
Stop. Because you've done that to me a couple of times. You've come back to me and said Rumpus called you a liar.
Oh, isn't that shit? But listen, I'm not playing you off him.
Do you get that? Do you get that? Just say you get that or not.
Yeah, I understand. But do you understand?
Then I'm not going to answer any of his claims because I did not watch firsthand him saying things.
Forget his claim. Do you understand that if he's going to argue, if he's arguing, not that he is arguing, but if he's going to argue 700 feet of curvature over 31 miles is enough to completely bring that land back, then it seems a little bit unrealistic to say that there's only going to be a pixel, is what you said, or maybe 10 pixels for if I was.
How are you getting 700 feet over 31 miles?
Because that's the thing that you kicked me out of your hangout for. That land needs to be 700 feet higher than what it actually is on a ball to explain how we could see it from the beach. 700 feet. That was the point. That was remember when I said you were going to kick me at a certain question? The question was, you can't explain this. So you
All right.
kicked me and said it was a
Hold,
Mirage.
hold on, sweetheart. I'll show you this. Watch this.
No, don't show me. Just what?
No. I'm not, no, because I'm not gonna shoot off the cuff just so you can use it in Nathan's Hangout.
No,
Hold on.
It's a simple concept. I'm trying
Well,
to get
it's
you
a
to
simple
see.
question, and it's going to have a simple answer. Now, hold on a second. Now, where were the locations? St. B's and what? It was Bride, right? Or the
Bride.
The berm by Bride.
Yeah.
All right. Hold on a second. So, oops, that's not St. B's. It's sad that I know more about St. B's than just crazy.
Berlin.
From the water. So.
Sad that you know more about St. B's than Berlin, perhaps?
I know quite a bit about Berlin, actually.
All right, okay. By the way, are you an American national or are you actually German?
No, I'm an American.
I was going to say, because you don't really sound like the usual
no,
crowd.
I don't have it. Well, I wouldn't call them Krauts, but what do you call it?
That's what they're known as, isn't it? Krauts? Or is that a derogatory?
It's it's a wee bit derogatory.
Oh, well, I didn't mean it that way. I just thought that's what they were known as.
Well, of course. All right, so let's see. 51.75 kilometers. Sound about right? To the berm?
51.75 kilometers. 51, yeah, 30 miles away. Yeah, that's right.
32 miles.
Sure.
All right, that's to the big berm.
Yeah.
Highest point in that area.
Yeah, and if you put my observer height to say, what, 10 feet, which is the claim by bloody Flat Earth Math.
Okay, let's go ahead and use the cannot escape from using perspective in a Earth curve calculator.
You mean
don't even.
I can't. I've heard it millions of times, but I can't remember it.
Yeah, well, the funny part is that he changed that title after he saw my video showing that the curve calculators do include perspective.
Really?
So, well, yeah,
let's not go there.
The day after, actually.
Well, I'll give you that. You can have. I don't know whether that's
I
true.
can even prove that, but that's fine. All right. So let's see. Distance in miles was. Oops. Measurement is 32.2 miles.
Sure.
Oops. I'm just hitting the wrong shit now. 32.2 miles. And viewer height was, we said 10 feet?
Well, it was nearer to like 1, maybe 2, but yeah, we'll go with 10.
Yeah, I remember even giving you 5 feet. So
we'll go with 5 then.
Okay. Now, hidden. Where are you getting your 700 feet from?
Well, I think I gave it at 1. I think I said I was no more than 1 foot, but I think some people argued 10, and then we compromised with 5. And actually, the distance is. I'm not seeing just that hill at Bride. I'm seeing the land that goes back on a different angle, and it varies
we're worried about the hill at Bride at the moment. Okay.
Sure.
One thing at a time. Okay.
So we're looking. The hidden value 639, and then with so it needs to be 639 to start with. But obviously the refractive hidden at 544 isn't enough to bring it back.
Okay, now this is what I'm going to show you here. Okay, because you guys keep on, use this 700 feet like it means something. I'll even give you the 700 feet just for.
Yeah, Rumpus has given it. Rumpus is giving. He's bending the light.
Like I said, I'm not here to argue what Rumpus did or didn't say out of context. Okay. Let's see here. Now, this is what I want to show you. This is a triangle calculator, my favorite one. Now, let's see. Hold on a second. What was that? 32.2 miles, right?
Yeah.
Let's see. We'll go. Since we're worried about feet, miles to feet. This is why I hate using miles and feet. Let's see. 32.2 is 170,016. Okay, so oops. Okay, so B 170 point oops 016. I didn't mean one put a point there. And I'll even get I'm just gonna put the numbers on. 639.8, right? 639.8, which is not 700. Just like
No, it is 700 if you go with the rest of the land. You're picking the first thing, the biggest thing at the front, the shortest distance. If you remember, that land goes back on a diagonal, and it's between 32 and 34 miles.
Are you trying to say that you can see things behind a hill? No, you can't. Okay.
No, I'm saying that you're picking the closest thing and not
Okay, now
declaring
check this
700.
out.
If you
Check
actually
this
put
out.
the one further back
Hello.
at 34, then you'll see that it is actually 700.
Hello. Okay. See this little A right here? This little bitty A right here?
Yes.
Okay. This is how many degrees bending that is.
Yeah.
0.216
Right.
degrees.
But you do realize that you're looking horizontal, right? You're not looking through a density gradient. You're looking through the horizontal.
No,
It's pretty
no.
much static.
What I'm saying is that is the difference. That is the degrees, like just like what we were just doing here, on here. That is the degrees down that is. Okay.
No, but hang on. Right, that's geometric, right? But if you're going to go into this one, which is a distraction, but if you want to do this, that's fine. But you've got to understand that when we're looking over evaporating water during the daytime,
Yeah, no,
evaporating water has a density medium that is less dense than the air that it's in. So that's the reason why the light would actually bend up, but not go down, because light bends away from the normal when it's going through a less dense medium.
Light bends when you are in the denser medium. Light bends in the direction of the denser medium.
Yeah, but that's only when it's going. No, when it's going through water vapor, evaporating water vapor, which it is when we're doing over water observations. The density, the refractive index of water vapor is less dense, and that means that light's going to bend up. It's only a little bit, but it'll still bend up.
It doesn't bend up, dude.
Yeah, it does. Look at the refractive index of water vapor compared to the refractive index of air,
Right.
nitrogen, oxygen, air.
But you realize now you're going against everything that you just said, right?
I'm just pointing out to you that when we're doing observations over water, the light bends up, not down. Sometimes it'll bend down. Depends on the medium. It depends on the conditions. But
if light bent up, you would lose boats in like about less than a mile.
Well,
and I'm talking about full on ships here.
Yeah, you're talking about you're basing the scale on a curve, right? On the curve already.
No, I'm just saying light bending up. Period.
Will cause things to appear to cut off at the bottom. I agree. I'm not disagreeing with that. It's the scale that's the dispute there, but that's again a different point. What the point we're trying to conclude here is that
no. Let me tell you the point that we're concluding here. Okay, the distance from St. Bees, as I just showed it to you, the distance from St. Bees to the berm at next to Bride. Okay, next to the rest of that land you can't see. The degrees. Okay, the mathematical degrees. Forget refraction for a second. Forget it. Okay, forget it. Okay, the degrees involved, the geometric degrees involved, okay, is only an offset. Just like we were just showing, what was the distance, or what was the angle versus the distance at the end? I'm just doing that backwards.
Yeah.
Okay, I'm reverse engineering exactly what you wanted to use.
Well, okay? You're not quite. We haven't got to my point.
Actually, I am. Hold on. And what it is that now, mind you, this is actually going to be downwards, because if we're talking about the curvature of the Earth, and using a curve calculator. Okay, mind you, we're testing the curve of the Earth here.
Actually, it would be up, not down.
What?
You got that wrong. The angle that you would be observing would be up because the mountains that we're looking at are 300 feet, and I'm up like 2 feet. Your angle would be up, not down. And if the Earth's curving away from me, the observer on the beach, then that means.
Oh my God!
The light ray is actually bending. The light is the ray of light from the thing is losing. It's going into a less dense medium because of the curvature of the Earth. And
Riley.
Yes.
Slow down, bud. You're hurting yourself.
You can't keep up. It's okay.
Okay, look. Here's a plane. Okay.
Yeah.
Just call this the plane. Forget everything else up here. Okay. Now, if we're talking about something that dropped 691 feet.
Sure.
Okay. Thereby resulting in a bulge that is part of that drop at 639 feet of hidden.
Right.
Okay? Now, which way is the Earth going? Is it going up or is it going down?
Which way is the light traveling?
No. Answer the question. Would the Earth be going down or would the Earth be going up?
Are we on a flat plane here, or are we on a curve?
I'm just saying, here's a plane as just a middle point, as like eye level.
Yeah.
Okay. What using an Earth curve calculator is the geometry of the Earth going up, or is the geometry of the Earth going down?
The geometry of the Earth would be going up.
What?
Put your mountain in at one end at 300 feet.
No. What?
Put your mountain in at 300 feet at one end. Put your observer at 2 feet.
Okay,
you have to be looking up.
Man, I really have to say this here. Hold on a second. You are saying that the geometry of the Earth, if I was standing here and this was my eye level, the geometry of the Earth goes up like that?
Right. We're either across. Right. Look.
When did you become LSC? You probably don't know that acronym.
Lord Stephen Christ.
Yeah.
I don't know.
Did you just go hollow Earth on me?
No. When we're looking over the water,
why would the geometry go up?
Because the mountain that I'm looking at, the hill, is 300 feet, 300 to 400 feet, but I'm at 1 foot, so I can't be looking down. I've got to be looking up.
Can you tell me a place where you have used the word drop meaning up?
I'm not on about the drop meaning up. I'm on about the mountain that I'm looking at being up.
We are using a curve calculator, okay? A curve calculator.
But you said we were on a plane.
Riley, listen to me, man. Okay? I am using the math in a curve calculator. All I did was I drew a plane here as eye level. That's all. Okay? I didn't say this is the Earth's surface. Okay? Drop means goes down.
Yeah, I know.
Do we agree?
Sure.
Okay. So that would mean that the Earth's geometry, okay, the surface of the Earth goes down, not up, right?
Yeah.
Okay.
But,
so, at least we're there, okay?
But we're not looking at the base of the mountain, are we? We're looking at the top of the mountain.
Just so you're not even letting me finish my sentence, dude. Okay, now check this out. Now, what we are looking for here is something went down something dropped 690 feet down from your eye level. Okay, per the math. Okay, mind you, per the math. And hold on a second here. Let me make this a little bit smoother. Okay, so something at this distance dropped. Okay, as in it went down here. Correct? That is the drop measurement, correct?
I understand. Yes.
Okay. Okay. Now, if with that drop measurement, I'm just going to hold on a second here. Rectangle. I'm just going to put a bogus thing here. It has nothing to do with the measurements of St. Bees or Mount St. Helens. Okay, just
sure.
So we're clear on that. I'm just putting just as a figure here. Okay, so this is an object that dropped this distance, right? Now, from the viewer's standpoint, a portion of that is missing. Okay, that's the hidden height. Okay, a portion of that is missing because of the obstruction of the curvature of the Earth, per the Earth curve calculator. Okay.
Yeah.
Okay. So the point that you need to understand here is that while it sounds exciting and somewhat dramatic to say that there's 700 feet of curved light, okay, you need to understand. You need to understand that 700 meters, which might be this, mind you, it's not. I didn't measure it out. Okay, that 700 meters is only about a tiny fraction of a degree of light being bent.
Yeah, over 30 miles.
Yeah, a fraction of a degree over 30 miles.
Yeah, but we know that, right? What you're not, I get that, but you need to understand that when that light ray on your model, when that light ray hits that peak of that hill at 300 feet, it then for it to hit your eye, it's got to follow the curvature of the Earth, but the Earth's always falling away from it.
Right.
So the light ray is getting less. It's going through a less dense medium all the time because the Earth's falling away from it. Do you agree?
Sounds about right.
Right. So when it's going through a less dense medium because of the gradient and because the Earth's fallen away from it, that's effectively going to start bending the light up just for that reason. In addition to the water vapor.
Why would it bend it up?
Because the Earth's fallen away from the straight line that the light's following.
About that, I'm not following exactly what your example is, man.
So your tangent line that you've got there that follows that it clips the surface, right? That imagine that that's the light ray that's going to eventually hit your eye.
Okay.
But it's not following the curve of the Earth because light doesn't travel in a curve. Light travels in a straight line unless it gets refracted, right?
Right.
But the Earth's always fallen away from that light, so it's going through less dense medium all the time because the Earth's fallen away from it. That's effectively.
Yeah, but in the less dense medium, the object doesn't exist.
So that right, this is our argument though.
No. I'm starting to get what you're talking about here, but the the less dense medium, the object doesn't exist there.
Correct. So
right.
obviously,
so why are you worried about what happens in the less dense medium?
So then, how do you have a mirage on a curve? An inferior mirage on a curve if what you're saying is just true? Because I agree with you. The light ray doesn't even get to you, but we see an inferior mirage over the curve.
That's not what I said at all.
No, but that's what the effect of what you said means.
No, it isn't.
Well, you just said that the light doesn't hit your eye if the curve's in the way, right? So that creates a problem when you come to an inferior mirage.
A straight line doesn't hit your eye if the object that you're viewing is obstructed by the surface of the Earth.
Sure, but we do see inferior mirages, and you tell us it's on a ball.
Are you talking about inferior or superior? Get that
inferior where it's underneath. So okay. It's how is that light ray getting from the image, the target, to your eye when the Earth curve's supposed to be in the way?
Who's showing an inferior mirage happening that way?
Well, this is what Rumpus has got to do.
You and Rumpus.
Rumpus makes claims.
Take your Rumpus arguments to Rumpus.
He won't come in the hat. He hasn't done it. He hasn't presented it, and he won't come in to present it because we know he can't do it.
Yeah, but Riley,
but my point is,
I am not Rumpus's keeper.
That's okay, but you do agree that we do see mirrored, reflective things underneath things, and we call them inferior mirages, right?
Yes, and do you understand why they're called inferior mirage?
Yeah. But how does that light ray that's supposed to be obscured by the curvature of the Earth, how does that light ray actually hit your eye when it's going over a curve? That is the obstruction.
Right, exactly. That's not an inferior mirage. You're talking about a superior mirage.
It works on it. Well, no, the inferior mirage, the one where it's reflected below the horizon of the thing above it.
Yeah, well, you got to show me the horizon on that first, don't you?
That's right, but that's our argument. Where is the horizon?
Well, that's what you need to be exploring.
Right, anyway, this is a tangent. Can we go back to the point? This is you're right. This is a rumpus.
Okay,
this is a rumpus fight, and I don't need to have it with you, and I don't really want to have it with you because he's going to lose, and I don't want to have a fallout with you on a tangent.
Well, let me tell you how you win or lose that particular argument. Okay, first prove where the horizon is, and if you have difficulty doing that, then the argument is moot until you do so.
That's our point. But anyway, I agree with that. That's our point that we will use against him. But
okay, because I can tell you that a superior mirage does not happen unless you have a curve, and it also doesn't happen before the curve.
All right,
I have video evidence of that.
All right, well, listen. Do me a favor. Let's get back on topic. Let's go back to the picture from Conspiracy Cats, and put.
Okay.
Actually, sorry. Have you got the picture of the side elevation profile that he's got?
No, I don't.
Can you go to his video? It's about halfway through.
What's it going to show me other than what I already have in my 3D model?
Okay, well, we can do it with your 3D model. It's just easier on his because you've got a lot of lines there. But all right, let's do it on your model. On the curved model.
They're confusing, yes.
Yeah. There's a lot of lines. Do you want to tidy it up so there's less lines? Are there any lines you can get rid of?
What are you looking for, man?
What my point is to do with, I know you said that you don't want to talk too much about the refraction, but if we can agree that the observer height of the mountain. I don't have any
problem with refraction. It's just that it's difficult to model out. And what do you call it? And you don't seem to understand that 700 feet equaling 0.2 degrees of bending of light is not very much.
And you don't seem to understand that the light is traveling away from the curve of the Earth because the Earth's bending away from it at all times, and it's going through water vapor when it's done over water, which also is less dense.
What do you want to see?
Hang on, I haven't finished. The light's bending away from the normal, therefore you've got two influences there that bend the light up. So you don't understand that. But anyway, you keep on saying up. I find that hysterical. But anyway,
Go ahead.
So, well, there's flat, dude. So it can't be anything other than up. But anyway, listen. The observer height on this claim is 327 meters. Agreed?
I think that's what it was.
Yeah, 327, and then Ranier is 4,392.
Mm-hmm.
So ballpark figure, Ranier is 4,000 meters taller than the observer height. Can we agree that on both models, either model, that we are going through a density gradient that is getting less dense as it gets higher?
Caused by gravity?
Caused by whatever.
Yeah, sure. There'd be a little pressure gradient, a pretty decent one actually.
Yeah, I agree. So as the light ray that comes from the sun bounces off the tip of the peak of Ranier and then goes into your eye, do we agree that that's going to go because it's going through that variable, that gradient? It is going to cause it to change slightly. It's going to basically it's going to bend the light down. I'll use the word down, relatively speaking.
I'll give you slightly, yeah.
Sure. Well, yeah, the gradient is how to quantify how much is the difference, right? That's where the argument is. But as long as we can agree that it's going through a density gradient caused by whatever magical forces that nobody can ever prove. But anyway, whatever causes it is irrelevant. But it is going through a medium, and it is variable, and it is getting less dense as it gets up, as it goes higher.
Without going through a barrier.
Sure. Well.
Okay. Cool.
Right, let's not talk about barriers, because I'll just say, well, how do you have the gas pressure first? And then you'll say gravity, and I'll say, really? Can you prove it? Right, let's come on, stick on topic.
No, I'm just clarifying the points. That's all.
No, what if we can agree that the light that hits the peak of Ranier and then that goes into the eye has been bent on the way into the eye because it's going through a more dense medium as it gets into the eye? We both agree that that's going to cause it to bend a little bit, right?
Mm-hmm.
Well, because
a little bit.
Yeah, but because the Earth is, this is where it gets different on both models, right? Because the Earth's curved, because of that curve, there's a difference between the rate of refraction on both models, right? Because the Earth's curving away on the Earth's coming. How's it going to work? This
curving down.
Yeah, it's curving down at all times, so it's going to have to basically follow more of a curve path than it does when it's on a flat plane because the Earth's not curving away from it, right?
Okay.
So the question that ultimately becomes is like, if it's going through these density change, this gradient, and it's on a ball, what's the value, what's the quantification of both models compared against each other to prove which is actually happening here? That's where the conclusion is going to be, and it's going to end up being moot, in my opinion. It's because neither of us are going to be able to prove one or the other.
Well, then here's what I'm going to give you here, because like I said, I don't know all this. There is an extremely heavy amount of math that has to be done to get the exact amount of bending of light, of refraction in the conspiracy cat's picture. Okay, the reason why is because of the fact that, number one, he's already at a higher elevation. Okay, these two objects here, Mount Rainier and Mount St. Helens, they're at a much higher elevation.
Yeah.
Okay, and their angle up is a little bit higher, and so the thing is that, and then you have temperature, humidity, and all those neat things that play around with this. Do you agree with that?
Yeah, there's a load of variables over long distances that
right, and we don't have those variables, do we?
No, but what we can do is we can basically use what Mick West likes to call.
Hold on, slow down. Now, Mount St. Helens is 86 kilometers away.
Yeah.
And Mount Rainier is twice the distance. Okay, a little more than twice the distance.
It's basically 50-50, isn't it?
Yeah, it's right about middle, right? And what do you call it? So, what you actually have to be able to prove is that this much elevation change, given now the height difference is also very different. Okay, Rainier is 14,000 feet, or excuse me, 4,000 meters, and St. Helens is only 2,500 meters. Okay, now what you have to actually be able to do is say that the amount of light that curves between here and here is actually greater than the amount of light that curves between here and the observer.
Right, and who has to do that? Is that us, or is that conspiracy cats?
That would be somebody with the competing view.
No, it's the one that makes the assertion.
No, it's not.
Of course.
Okay, let me tell you why it's not. Okay, you ready for this? You're gonna hate me for this.
This is going to be called a burden of proof reversal fallacy, right? You realize that?
You can play whatever fallacy game you want. Okay, let me tell you why. Because you see, the other night, and the whole reason why we're actually sitting here is because the other night I modeled this out. Okay?
You modeled what out?
I modeled the two mountains out. Yeah, I mean you knew that already. That's why you told me to bring up the one I was working on the other night. And
oh yeah, Conspiracy Cats told me to look it up, to look at what you did. Yeah, so I was aware of it as of today.
Right. Well, I don't care when you were aware of it, but you are aware that I modeled this out.
Correct.
And now, what you have to come up with. This is the view.
Whoa! What? That is the burden of proof reversal, mate.
No, it is.
Yeah.
This is me proving the observation.
No, it's not.
Yes, it is.
Yeah. How are you addressing the effects of refraction?
You give me the numbers for refraction, and then I'll gladly put them in here. Got it?
Well, I can do better than that.
No, I'm sure you could try, but what do you call it? When I look at the camera that was on the curve, okay, where Mount Rainier and the bulge, as per their stated measurements and distances, and the stated and proven by modeling it, the R of the Earth.
Okay. So by modeling it, you prove R. Really? I'm sure Nathan would love to hear that.
Nathan doesn't hear because Nathan doesn't do work.
So by modeling R, you prove R. Really?
Yes.
No. Do you know what the definition for a radius is, Sly? In a sphere.
Mm-hmm.
It's the three-dimensional center of the sphere to the circumference, right? Three-dimensional in all directions. Right. You don't prove that there's a radius to a sphere by modeling this on a computer.
Well, why does radius exist on a 2D circle?
Well, that's irrelevant. It's a 2D circle.
No.
That's our...
No, the word radius is not selective.
Okay. No, it's not selective, but that would be our argument, right? The radius is only to do with the path of the sun, and it's on a two-dimensional flat plane.
What the fuck does the sun have to do with it?
Well, because the sun is circling above a flat plane, is it not?
No.
On our model, it is, right?
So you're claiming the AE model?
No, I'm not claiming any model, but what I'm saying is that your perception...
You just made an assertion. You made an assertion of what the sun's doing.
Hey, you're not going to ask me for proof, are you?
I'd love to, but you ain't going to give it to me.
Well, yeah, but you understand that the burden of proof is on he who asserts, right? So when it comes to
you're asserting I'm lying. You're asserting I'm wrong. Even though I can model it out.
No. Right, make your points. Come on.
Look, let me give you something to go back to Nathan and have him flip out.
Make your point.
Okay, my point is that when I model this out, now obviously we both agree what a plane is, right?
Yeah. Okay.
Okay, so that we're cool on plane, right?
Yeah.
Okay, so plane is straight line. So when I apply the elevations that exist for Mount Rainier, Mount St. Helens, and that bulge thingy on the side of Mount St. Helens, which you got wrong. Okay.
What do you mean we got wrong?
Oh, you were pointing at the wrong fucking thing. You guys were looking at the backside of the mountain.
We're asking what is the elevation for that bulge that he's claiming because we can't find it.
You couldn't find it.
Correct. We could not find the elevation data for what he claims is the bulge because we couldn't get it to match.
Fucking Christ, man.
Well, don't you do it and wait for him to do it.
Do you guys not do any work? You just sit around just asserting shit or what?
Okay, so go on then. Show me how we get where that value comes from then.
I'll show it to you. Watch. Okay. All I did was draw a line.
6505.
What?
6505 feet.
I'm in meters.
1982.
So here was his stated observation point.
Yeah.
Which I accidentally missed by about 10 meters just drawing a line guesstimating. Okay.
Well done.
And now, if you follow that line to St. Helens, right? See me following the line to St. Helens? Okay, this is the line to St. Helens.
Yeah.
Raise up an elevation just a little bit. Okay. It's not hard to find out just by looking at the picture that was taken by, it's actually not Conspiracy Cat's picture, it's actually a friend of his. And but nevertheless, here's the picture. Okay. See this little bulge right here? It's not hard to find that.
Go on then.
Okay,
Point it
so
out.
it's a geographic feature right here,
Yeah, point it out.
right here.
Right. So the elevation for that bit there is what?
Where he had his line is about 1982. That's what. Oh, I got 1995 in front of me here.
And
About
what?
1982, right here.
So where does that value come from?
What do you mean? Where's it come from?
1980. So you're identifying the peak, that peak as that, but where does the 1982 bit come from?
Look in the lower right of my screen.
You're using Google Earth to cite that peak on a mountain?
Well, I can test it, can I?
Well, you might be able to test it, but do you not remember what happened when I cited something from Google Earth on the Isle of Man stuff?
Are you saying that you can't test the information on Google Earth?
Well, this is my point. We've tried to validate this information and we're not able to validate it anywhere.
Well, because I've seen how you guys do math. But what do you call it?
Well, it's not necessarily maths.
Nevertheless, here's the bulge that is in discussion. Okay, the quote unquote side peak. Okay, this is it. Now you and your buddies were using this thing, okay, which is visible from the back side of the mountain when you guys were trying to come up with prominence having something to do with the slide area here, which that's not where you get prominence from.
No, that's wrong. You just totally misrepresented what we were doing.
Well, I'm just going by the sketch drawing that you had that you were trying to say that between here and there was 640 meters or something, or feet, I think. But nevertheless, now I mean you can argue that point, ad nauseum, but I don't care. Now, nevertheless, looking back from here, you can. This is called terrain identification. That's all it is, man.
Yeah, I understand what it is.
Okay, so that's where you get that you can get that height from. Now, when I originally modeled it out, okay, because what I like to do is I like to test the information that people are given. Okay, when I originally modeled it out in this, okay, I used the exact height that he stated. Now, the reason why I used the height that he stated is to check his information. And guess what? If it checks out, then it checks out.
Yeah, but that doesn't prove the height, though.
No. Yes, it does.
Well, that's also susceptible to backwards engineering, though, right?
You can forward and reverse engineer it. It doesn't matter. I forward engineered it here.
Yeah, but that doesn't prove that the height's accurate. That just proves that it models.
It proves that the height is accurate. Otherwise, it wouldn't model correctly.
No, it doesn't prove that the height's accurate. What proves that the height is accurate is getting supporting evidence. Right, anyway, make your point. Make your point.
Okay, my point is this, okay, because I know you don't want to hear the point. The point is this. If you gave me a bunch of numbers for different locations and I put them to the stated diameter, or excuse me, radius of the Earth, okay, then I'm actually testing those numbers. And obviously, if the observation and the model don't match, then obviously something's wrong, right?
Correct.
Okay. I mean, you agree with that. But
yeah, of course.
But if I model it and it matches, that confirms both the heights that were given.
No, that's a reification fallacy.
Wait, so if it doesn't work, then you're cool with it. But if it does work, then you're not cool with it?
Well, just because it matches in a model doesn't mean it necessarily matches real world.
Well, you just tell me it does.
No, it doesn't. It helps, but it doesn't prove.
No, you just told me that putting the measurements in a model, and if it doesn't work, it's incorrect. Right?
No, it doesn't prove the point that you're saying.
If it doesn't work, it's incorrect, right?
Correct. If it doesn't work, it'll be incorrect. Correct.
Right. So you're happy with that. Now, but if it does match,
that doesn't mean it's true.
Then what does it mean if it does match?
It just supports the assertion. It doesn't prove that it's true.
So you're saying that if it does match, then it works.
No, I'm saying if it does match, it supports the assertion, but it doesn't prove that it's true.
Well, where do you cross those lines?
Because you're using a model.
Where do you cross the? Yeah, you got to model it out to test it.
It's like saying that maths proves something. Maths can't prove anything.
I can't go to the state of Washington, take a cross section out of their landscape, and bring it back here to the house and measure it out.
No, I agree, but you got to understand.
So what I have to do is I have to use the information that somebody has stated, somebody has gone out and done a measurement on, and then I can use those measurements to build a model to test if the information is correct. Do you agree with that?
I agree with that.
Okay, and if the observation fits the model that I did with those measurements, you're saying it's not right.
No, I'm saying it doesn't prove the point. It just supports.
Yes, it does.
No, it doesn't. A model doesn't prove anything. A model is
Does
a model.
too.
No, a model doesn't. It's like saying that maths proves things. Like math is reality. No, maths
but
is
you
not
just
reality.
came to me with math. That's what I opened this show with.
Yeah, but maths isn't proof of anything.
No. You came to me with math.
Yeah, but it doesn't
hoping to prove a point.
It doesn't
and
prove
because it
something.
didn't and because
all
it
it
didn't
does,
prove it,
all
you're
it does
saying
is
it doesn't
supports or it doesn't support, but it doesn't prove. It's a reification fallacy to say that it proves something.
Riley, I don't give a shit about what kind of fallacy you claim it is. I'm not going to look up the definition of every psychological fallacy that exists.
Okay? Yeah, but if you're using a model to claim that something proves something, no. A reification fallacy is using a concept or a model as proof of real world. Well, you can't do it. If you're going to prove curvature, you've got to prove curve, not models.
That's what I did. That's what the model does.
But it's a reification fallacy. It's a form of logical fallacy. If
so you say that you can model it out, but when you model it out, then it's some kind of fallacy.
Yeah, it's a reification fallacy.
Then what the fuck is the point, man? What
just does it support the claim or does it not support the claim? But it doesn't prove.
It supports the claim.
It doesn't prove the claim, though.
It does.
No, it doesn't. Look up the definition of a reification fallacy.
Oh, Jesus fucking Christ, you're going in a goddamn circle.
No, I'm not.
Riley, if I can measure it out, okay, tell you what, if I can measure out the, let's say, you know that berm you were standing at St. B's, you know, that big tall berm you were standing at, that everybody had the argument about how high it was?
Sure.
Okay. Now, if I was an architect, okay, and I sent Sean out to get measurements of that berm, okay, you know, tell me how high it is, what's the difference between this angle and stuff like that, and he brings it back to me, right? Sean comes back to me with these numbers. That's all it is. It's numbers, right? And I turn around and I put it up here in CAD, right? I sit here and I model out those numbers, and it ends up, you know, looking like some kind of weird thing. It looks like, you know, it goes like this, you know, whatever his number was that he gave me, okay? Now, and that berm looks like this. Now, some real rich fucker comes to me and he's got, you know, millions of pounds, and he wants a house on stilts there, okay? You know, I mean, there's rich people in the UK. You're not unfamiliar with the concept.
Sure.
Now, if I got those measurements from Sean, okay, now the first thing that I'm going to do, you know, I'm going to sit here and I'm going to design out the house, and then I'm going to design the height of the stilt, because this shit costs money, okay? And it's not one of those things that they just kind of wing it when they get out there. You know, this shit costs money. And so to get these, that means I make a model on paper usually. Okay, make a model on paper to get the lengths and how much mortar or how much concrete I'm supposed to put down here in the ground, and the sizes and the volumes and all that other stuff. Modeling things out is a representation of reality.
Yeah, but it's not reality, is it?
Of course, a CAD drawing is not actually me having a cross section of the state of Washington. Okay, of course. You're just itching for me to say that it doesn't match reality, but it matches reality.
But that doesn't mean it's true.
Then how does something matching reality not mean it's true?
Right. Share my screen if you.
How does something? No, I want to hear your answer first.
I'm going to show it with something called evidence that proves that your claim is wrong. So present my screen.
What claim?
That something that matches on a model means that it matches real world.
All right, so oops, that's me.
So we'll start with the definition so that we're on the same term.
I'm not going to go through definitions with you.
No, I'm going to show you evidence.
No, I see what you got up there, and I want you to show me how doing a model does not represent reality. I don't care about what it is. I see what you got there.
In other words, it is the error of treating something that is not concrete, such as an idea, as a concrete thing, like a drawing. A common case of reification is the confusion of a model with reality.
Okay, now, but you just agreed with me that
when
I can model out that hillside.
So when the engineers of this bridge built
this bridge, faked. That bridge is fake, dumbass.
So you're saying, what evidence have you got that proves that that's fake?
Oh my God, really? Hold on. Let me please share your screen. Hold on a second. Okay, everybody. Riley is saying now. Now go back to the other one. Go back to the other one.
Oh, hang on. That one.
Okay. Now apparently this is something real, and this is his support of his argument. Everybody cool with that?
Yeah.
Okay. So now the question is, you've already said that you can model reality. But now, when it comes to the size and shape and curvature of the Earth, you can't model reality. So which one is it, dude?
No, you've misquoted me.
No, I haven't.
You have. I did not say that. What I said was, if it matches the model, it doesn't prove that that's true, because it's a reification fallacy. You can't prove curvature with a model. The only way you can prove curve is by proving curve.
Okay,
Do you
now
read
tell
the
me
definition of curve?
Now tell me why you can't produce. Why you can't. Give me the specifics of why you can't prove curvature with a model.
Because it's a reification fallacy.
I don't give a shit about a fallacy name. You tell me why you can't model out the curvature of the Earth.
Because it doesn't prove curvature.
No, that's not what I asked you. Why can you not model out the curvature of the Earth?
Because it doesn't prove curvature.
You're still not answering the question.
I am.
No, all you're doing is saying because it's curvature.
No,
you know, I mean
because it doesn't prove curvature.
But you just said that I can prove, I can model out reality.
No.
So why can't I model out a curve?
I said you can model a sphere using a model. However, it doesn't prove that the thing that you think you're looking at is a representation.
When you model it and it matches your observations in reality, then guess what it does? It proves that.
No, it doesn't. It can't prove anything. All it can do is support or not support. It can't prove
support
anything.
Or not support. Guess what? Everything that I've modeled has supported, which you are going to now use as just an adjective, supports the model or the curvature of the Earth.
It doesn't though.
It does too.
It does not. Because here, let me go through this.
Here, so, no, I'm done listening to this stupid shit. Watch.
No.
Watch. Camera.
No.
Flat camera. See this?
No, hang on. I'm picking you up.
Do you see this?
No, give me a sec.
You don't see it.
No, wait a minute. I'll get back to the screen.
Present everyone. Now do you see it?
I do now.
Okay, you see it.
Yeah.
Do you know what these things represent?
I do. One is the mountain in the foreground, one is the mountain in the background.
Actually, there's three things. The green is the height of that bulge thing. The purple is Mount St. Helens, and the red is Rainier. Okay, this is across a plane. This is what it results in.
Right. So
now hold on. This is across a curve based on the same numbers that you and your buddies all hate. Okay, and guess what? That bulge is now the exact same height as Rainier.
Right.
Just like it's shown, hold on, when you compare it to reality, okay, just like it's shown, where was it? Okay, this one right here is the flat Earth versus the picture. Guess what? Doesn't work.
Right. Okay. But do you realize that
Hold on, I'm not done yet. Okay, this here is the curve Earth against the picture. Guess what? It matches. So therefore, it verifies the information. Therefore, it proves that the information is correct.
No.
Therefore, it verifies and proves the model is correct.
No, it doesn't prove anything. It simply supports it. However, it doesn't mean that it's the same thing, because our explanation is that you guys
not the same.
You guys have hijacked perspective and called it curvature.
No, hijack also actually means that it still exists. So check this out.
Right. So the word meaning of words is important when it's for you, but when it's for me, that you just don't want to know about the reification.
No, because I know the kind of fucking word salad you guys play with this shit.
Okay? No, it's a fallacy. It's a logical fallacy. What you're doing is using.
Are you saying this picture is a logical fallacy?
Yes. Which picture?
How?
Hang on.
Have you modeled one out?
No, that picture's not a reification fallacy. Your model is a reification fallacy.
No. This is based on my model. You moron.
Right. It's not.
This is based on my model. Do you agree or not?
No, I don't agree. It's not based on
your model. You don't agree that that's based on my model?
No, not at all.
Why not?
Your
Why
model,
not?
because that came first.
Why not?
Because that came first.
Why is this not based on my model when I use my model's measurements to make it?
Your model is based on the picture.
didn't. No, it's not.
Yes, it is.
Are you saying that I drew the picture just to match, or drew the model just to match the picture?
No, I'm saying that you're using...
Yes, that's what you're saying.
I'm saying that you're confusing a model with reality, and that by definition is a textbook reification fallacy.
Look,
this
is a textbook proving the measurements, proving the distance, proving the curvature of the Earth.
Yeah,
I know you don't want to hear that.
On an Earth without any atmosphere.
Yeah, and you might get about
a pixel out of it, is it?
You might get a pixel out of that. Do you realize how zoomed in this is?
Right, but Rumpus is explaining with 700...
I don't care about Rumpus.
Yeah, but I'm not giving you a pixel.
And I don't care about Rumpus.
Well, you're not having a pixel. And it doesn't prove that...
Really? Then what about all of your... Well, there's all this compression going on and all this other stuff. You guys move a lot of pixels, dude.
No, we don't move any pixels.
You move a lot of pixels, dude.
Oh, you're losing your temper?
No, I'm pointing out your fallacies of not being able to support your own fucking model.
So you deny that the compression of the boat that Ranty shows over and over again...
I've seen it, but according to you, we can't have a pixel. There's a lot of pixels in that, don't you think?
No, what I'm saying is...
Do you think there's a lot of pixels in that, yes or no?
So you're going to like stamp over me the way Nathan does, right?
No, I'm going... Yeah, exactly. I'm going to go Nathan on you right now.
All right.
Okay? Because I need you to answer the fucking question.
Let me know when you're done.
Riley, you got anything else for me tonight, or are you going to model anything out?
Well, I've had my screen shared for about 40 minutes waiting for you to flip me back on.
Right, because all you want to show me is a definition on Wikipedia. While you're there, I want you to look up the Earth.
Are we done here, or am I going to get a chance to share?
Hold on a second here. Let me just point something out to you here. Let's see, Earth. Since you're going to bring me stuff from Wikipedia that you think supports you, here's Wikipedia. Earth.
The thing is, though, the reification fallacy is demonstrated and defined everywhere. It doesn't.
I don't give a damn about your definition of a fallacy.
Where's that Earth verified anywhere else?
What's that?
Where's that?
I just verified it here in my model, but you said models don't do that.
Yeah, it's because it's a reification fallacy, dude. You don't have to accept it, and you don't have to like it.
Man, you know what? When you actually prove flat Earth, you let me know.
You prove that curve, mate, and I'll be on your side.
I just did.
No, you didn't. You did it in a model without any atmosphere. And
really? How are you going to prove flat Earth? How are you going to prove flat Earth to me?
I don't have to prove flat Earth.
How are you going to prove it?
Proving ball.
How are you going to prove it?
I don't have to prove flat Earth. I don't necessarily think it is flat. I think it could be something else.
What can it else be? What can it be?
Well, it could be a what's-it. It could be a Pringle. It could be an onion ring. It could be any shape. It could be a comet, an asteroid, a bogey.
Well, then you let me know when you model that. Cool?
Cool. But I'm not the one making...
Anything else tonight? Anything else tonight?
Absolutely. I've been waiting for you to share my screen before.
I'm not going to share your Wikipedia entry.
No, I'm not going to go to Wikipedia. My point is about refraction.
What about refraction?
Are you going to share my screen or not?
I'm going to share it, but man, I don't know what you're going to show me if we're not allowed to model things.
No, I'm not saying you're not allowed to model it, but you're not allowed to claim that it proves anything because it doesn't.
Well, then what are you going to show me?
I'm going to show you the variations with regards to the refraction.
On what? A model?
No. Look, am I screen sharing or not?
On what? A model?
No, not on a model. On
even better. Text.
Data.
Cool.
Data.
Yeah, I use data too, but we're not allowed to use that because that produces a model.
No, you're all right using a model, Sly. You're not understanding my point. It doesn't.
No, because when I show you a model, all you say, "Oh, that's this fallacy" and stuff like that. Well,
it doesn't.
You do not realize
anything. A model
doesn't prove it. So your text is going to prove something to me?
No, I'm just just let me present.
You're presented?
Right.
Is your text going to prove something to me?
Just shut up and listen.
Or is your text going to prove something to me if I can't model it out and give you a visual?
Close your mouth and open your ears.
Answer the question, please.
What's the question?
It's nice to know you're listening. Is your text going to prove something to me that my model and an actual graphic representation couldn't do?
No, models don't prove anything.
Well, you're giving me text, which is data, okay? And that data will be put into a model to create whatever end result that you're looking for. That's building a model, but you just said that models don't do anything.
All right, we'll just finish on this then.
Did you understand that or not?
No, I understand. And I realize that what you're doing is using it to censor me, and that's fine. I don't mind.
I'm not using it to censor you.
Yeah, you are.
I'm using your logic in your direction.
Yeah, but the difference is I let you present your reification fallacy. You're not letting me present a counter.
No, what your counter is worse than what you're claiming my shit was.
No, it's exactly the same.
It's exactly the same.
Yeah.
You know?
What?
Sorry, I had somebody at the door. Anyway, so go ahead and show me your non-reification fallacy.
No, I'm accepting
no, go ahead and show it. Go ahead and show
it. Do we agree the density of the air changes as it gets higher, right?
Yes, it gets
at 300 meters. The density of the air is about 1.17 roughly, and then at 4,000 meters, it's about 0.7 roughly.
Yep, yeah, without a barrier, yeah.
Sure, without a barrier, yeah, without gravity too.
Good luck with that.
Yeah, my point exactly. Right, so I've got 4 files I'm going to show you, which are all reification fallacies and don't prove anything, okay? First off, we have, this is what it would look like on a flat plane without any atmosphere whatsoever, in a vacuum of space, right? That's what Ranier would look like relative to this mountain in the foreground.
Hold on a second.
They're about the same size without any atmosphere.
Yeah, about the same size, yeah.
Yeah. But then when you have the flat plane...
Yours is a little bit lower than it should be, but okay.
When you have the flat plane with an atmosphere, Ranier, because of the distance, gets a little bit further back. It gets a little bit further down. And I use the word down, relatively speaking. Relative to the mountain in the foreground, it gets down a little bit. That's the difference between refraction on both, on the flat plane. However, on the globe, that's where Ranier should appear because of the curvature. That's the difference between a curve and a flat plane.
Wait a minute. How are you getting that?
Well, that's why I'm waiting for conspiracy flaps to get back to me.
No. How are you getting that?
I'm not telling you how, because it's based on information that is incomplete.
Oh, I see. So you want to use stuff that you're not going to tell me about as proof of something?
Well, we're not.
And isn't that a model?
Yeah, it's a reification fallacy.
Okay, so why are you showing it to me then if that's not valid?
Because the effect of refraction on a curve means that...
Why are you showing it to me if it's not valid?
Because if you're going to claim that models prove stuff, then I've got a model that proves stuff too.
But you've already said that you don't... Yeah, you've already said that you don't support models because there's some kind of a fallacy.
No, that's not what I said.
Yes, you did.
Are you able to... Are you doing what Sean does?
Listening and giving you your words back, yeah.
No, my words were a common case of reification is the confusion of a model with reality, which is what you're doing, but is not what I'm doing.
Well, the confusion of a model with reality is actually the flat Earth model because it doesn't comport with reality.
Well, I've got it modeled.
Well, no, actually, I'm right.
Right. So then we have to go back to this. Do you agree that on the flat Earth model being reification, but nonetheless model, do you agree that the height of Mount Rainier should be about the same height? It should appear as about the same height as Mount St. Helens, yes or no?
It should be a tick just above it, yeah.
Yeah, it's about, we'll call it about the same. But when we factor in a bit of refraction, because we're going through a density gradient, that light ray is coming from, what was it, 3,000 meters down to 300 meters, I think it was, or 2,000 meters, or whatever the value was.
Where's the refraction on St. Helens?
It does move down a little bit, look. It doesn't move down at the same rate because it's out half the distance.
Wait, what?
St. Helens is moving down a little bit, but Rainier moved a lot more because it's double the distance away. That's the difference between the two of them on a flat plane with and without refraction.
That's
impressive, right?
No, it's not.
It is. Anyway, point is, we have flat with the atmosphere and flat in a vacuum. Flat with the atmosphere, flat in a vacuum. But then we go to your one.
Oh, you got something to support that?
Yeah, but it relies on...
You have something to support that?
I do, yeah. I've got it. I have the model.
What do you have to support that?
Well, I need to verify the claim first. That's why I need conspiracy flaps to show his proof.
How can you verify it then if we can't use a model?
Well, we have something called density gradients, correct?
How can you verify it if you can't use a model?
We know that the density at different levels is roughly these values.
Jesus.
Are these reasonable values? Would you say that these are reasonable? there or
I don't know
thereabouts.
the numbers off the top of my head, so I'm not even gonna affirm
Well,
or
that's
deny
okay. But
that
this
at
is
all.
these are the factors that we put into the refraction calculator,
I'm sure you probably did.
the refraction emulator within the model that was used. Now, the other
Fine.
thing is, let me just go back to this one.
Okay, but why do you continually refuse to answer my one question?
I ain't
How
refusing
are
to
you
answer
going to prove whether or not conspiracy cats brings you something valid or not if you don't model it out?
because, right, you can't prove anything with a model.
But okay, so in other words, what you're waiting for is him to give you information that is going to be useless.
Correct.
So why waiting for him?
Because I want him to prove validate his. I want him to prove the facts
Yeah,
first.
but how are you going to prove that?
I'm not. He is.
Okay,
It's not
but
my
if he can't
assertion.
if he can't model it out, then how's he going to prove it?
Well, like I say, reification fallacy states that
If
using a
he can't
model,
model it out, how's he going to prove it? What
you're
proof
not
are you
you're
looking
not
for?
going to prove curvature by looking at the horizon.
Yeah, that's interesting. Not looking at the Earth. Yeah, okay, but that
Right,
doesn't
I'm
even
going to
make
close
sense,
with this
dude.
because we obviously don't agree with what the value of a
No, the
model
thing
is.
is that you are leaving an open-ended discussion of which there is you have blocked every avenue of proof that exists.
No, I'm not.
Okay, then
Proof
what
of
proof are you
curvature.
waiting for? What proof
Proof
are you waiting for?
proof of curvature is not found within a model.
But
I
how
know,
do
I
you
know you
prove it?
want it to be, but it isn't.
But how do you prove it?
By proving curvature.
But how do you prove that?
Well, do we need a definition of curve?
No, but I need a definition of how would you prove that in a real-world observation.
Well, this is not my problem, is it? This is your problem.
No, it's your problem because you guys want to see proof. However, you have blocked every avenue of proof that could be provided.
No, because
So not allowed to talk about NASA. Not
what
allowed to
you
use
claim
Earth
is
curve
proof.
calculator. Hold on, shut up. Not allowed to talk about NASA. Not allowed to talk about Earth curve calculators. Not allowed to model things out. Okay, so what's left?
Well, if you're going to prove curve, you're going to have to
What's
prove.
left?
If
What's
you're
left?
if you're going to prove curve, the definition of curve is a line that gradually deviates from being
I
straight.
know what a curve is, you
Right? So how are
moron.
you going to do that with a model?
You
That's
can
not
draw a
proving.
curved line.
Right? That doesn't prove that the line that you're looking at is curved.
When you can raise up the objects that you know the altitude of, yes, it does.
No, it doesn't, because as Blago
Okay, so
rightly says,
hey. What proof are you looking for? How
proof
would
of
you
curve
how would you like that presented?
by satisfying the definition of curve,
Yeah.
not model.
How would you like that presented? Because I've already shown left to right curve on Rob Skiba's balloon at the measurable
Don't be
amount.
ridiculous, dude.
At the measurable amount. Did it live.
Oh, well, whatever.
Okay, but you know, that seems to be the only thing. And now you're dismissing. You probably haven't even watched it. But but the thing is you are creating an error to require proof of which you cut off every avenue of possibly providing proof.
No, I'm just telling you that the problems with what you claim to be proof are prevalent. You can't claim that there is proof when you're using it on a model, because by definition, a model is a reification.
Okay, but you have not. Yeah, I understand that's your definition. Okay,
That's
I
my
understand.
definition.
Hey, I understand what you're saying there, but you have not said, well, what proof do you require?
I no. What do you mean? What proof do I require?
Okay, if I were to walk up to you right now and I say, Riley, you want proof of the Earth being curved? How do you want to see it? What would you accept as proof of the curve?
I would want to see proof that there is a line that deviates from straight.
Okay, but that's been shown like 100 times.
Really? Where's that?
Yeah. Well, I'll give you one. I'll tell you what. Look at Rob Skiba Proves the Globe. It's a video of mine.
According to Slice Marcane, right?
You can argue
Well,
it if you want to.
The whole body of science is touted as being proof of the curvature of the Earth, right? That's frequently the phrase that comes up from people like the Rumpus and now
I don't care. Don't bring Rumpus
Ruhif.
Okay, and don't bring Ruhif to me. I'm talking to you.
Yeah, but how are you going to prove to me curvature of the Earth?
Exactly. How am I going to prove it to you if you cut off every manner of being able to prove it to you?
Yeah, but you're the one making the claim, and I'm saying
but you're the one requiring the proof of the claim. So, what is it that you would accept as proof of the curve of the Earth?
Something that shows a curve of the Earth.
Yeah, okay, but in what way? Left to right curvature, drop curvature, because you've seen them all.
Sure, but none of them are basic. The problem we have is a different standard of evidence for what we consider
You
to be
haven't
true.
defined your standard of evidence.
Right.
All you keep on saying is that what everybody else does is some kind of a fallacy.
I'll say it again because you interrupted me. You and I have a different opinion of what the standard of evidence of proof is. You think things like pictures from space is proof. I don't. I
Okay.
think that science, given that that's the standard that we're supposed to be accepting, should be able to demonstrate the curve everywhere on the earth all the time.
And we can. This is a picture in Washington State, dude.
Yeah, but as I demonstrated with
No,
my
you didn't
model,
demonstrate anything.
I did.
Because what you did was you used a model which you said you're not allowed to use. So
I
by your own standards, you didn't show me anything.
I demonstrated that my model, the way I modeled it,
but we can't model things. Hold on, let me bring up that fallacy.
No, the reification fallacy. No, I didn't say you can't. Why are you not why are you misrepresenting my words?
Because you are being subjected of when they apply.
I'm not.
Yes, you are.
I'm not using this to prove.
Why are you showing me a picture of a model?
I'm not using this to prove anything.
You're not using it to prove it. Then why are you showing it to me?
Because I'm just showing you that we can model it out.
Why are you showing it to me then?
Because the conclusion of my point is what Blago says.
But you just said that the conclusions of models don't prove reality.
That's right.
Didn't you?
That's right.
Then why are you showing it to me?
Because I can counter model you and no one knows which one's right.
You haven't counter modeled anything. You use somebody else's shit.
I can counter model and nobody knows which one's right.
Oh, so you can counter model now. But so counter modeling doesn't fall into the fallacy, but modeling does.
What's the difference between counter modeling and modeling, Sly?
That's what I'm asking you, because you just said you can counter model. Okay,
yeah,
if you can counter model, then why can't I model?
Yeah, but my point is that you accept a model is proof. I don't. But I can counter your model with my model.
If I can model something and it matches reality.
Yeah, but it doesn't prove cause. It doesn't prove.
Oh, Jesus fucking Christ. Yes, it does. Because when I turn around and I show you a flat versus a curve, right? Here's the flat. Oh, wait. I'm not even presenting. Oh, no, I am presenting. Okay, if I can show you it on a flat and I can manipulate the independent variable in this case, which would be the surface from which all of these measurements are made from, okay, if I can adjust the independent variable and I can match reality with that adjustment of the independent variable, then guess what? I have proven, if not verified, the information that I used to arrive at that conclusion. Didn't I?
Do you know what an affirming the
Didn't I?
Sorry, I wasn't really listening. What was your question?
I know you weren't. Okay, because you don't fucking listen. Okay?
What was your question?
Never mind, man. You can play it back later. You got anything else tonight, man?
Well, the reason why
you got anything else tonight?
Yes.
What?
Present my screen, please.
Because I'm not trying to do this all night, man.
No, this is my last thing, and then we can go.
There you go. You're presented.
The reason why you can't use a model to prove something is because all you're doing is affirming the consequent.
Okay, but then you can use the counter model according to you.
Yeah, and that's my point, though. That's not your point. That's my point.
Right, but if you can use a counter, what's the difference between a model and a counter model?
Because you're claiming
what's the difference between a model and a counter model?
Stop interrupting. You're
claiming the fucking question. I won't have to.
I'm trying, but you're interrupting. You're using the claim that your model is therefore reality, right? I'm saying that my model is also reality.
But so you can't use a model.
Which one's true? And the answer
is use a model.
Which one is true? The answer is we don't know. But the reason why it can't be accepted to be truth is because it's an affirming the consequent. If A, therefore B, we see B, therefore A must be true.
Right. And that's what I have.
Yeah, but it doesn't necessarily follow that what you're seeing is the same as what you're saying it is. Actually, because there are other things that cause it. The reason why we know that is because the effects of refraction in the atmosphere when looking through a density gradient does change things. The question is to what rate?
Riley, my independent variable is the curvature of the Earth from which my MSL measurements are made. Do you agree?
And how are you going to manipulate your independent
variable? Do you agree?
Yeah. And how are you going to manipulate it? You must manipulate your independent variable.
Right here on the screen.
No,
You
that's not
moron.
proving cause, though, is it?
You just told me that my cause is the damn the curvature and the measurements that I get from MSL above it. If I can manipulate that, then guess what? I'm proving that. Do you or do you not agree?
How do you manipulate the independent variable if the independent variable is the curvature of the Earth?
I can do it here in the model.
Yeah, but how do you do it in real world to prove that it is the thing that you're saying that it is?
So you need me to go out and make this out of dirt?
How are you going to manipulate?
Do you need me to go out and make this out of dirt? Does that satisfy your reality?
Do you agree that you have to manipulate your independent variable inside?
Yes, and that's what I've done.
Right. So how do you manipulate the curvature of the Earth if that's your independent variable?
You model it.
No, that's not manipulating it.
That is that putting together a model allows you to have full control over the manipulation of the independent variables.
But you're not manipulating it. You're modeling.
Yes, I did. Look, this is a manipulation. Look, all these heights are the same height off of the surface. One is on a curved surface as per the stated radius of the Earth, and the other one is across a flat plane. Guess what? That's manipulating the independent variable
in the model.
Riley, you have a nice night, man.
Have a good day.
Go and get. Ladies and gents, so apparently you can model things if you are countering an argument, but you can't model things to support an argument. And being able to manipulate the items in a model is apparently not manipulating the independent variables to find out the cause of an observation, and thereby also showing the comparison of the two causes to find out which one matches the photograph. Apparently, that's not right either, according to Riley World. So, ladies and gents, that's all I got. Actually, 15 minutes longer than I wanted to be on this. So, I hope you guys all have. Riley, you're a moron, man. I hope you guys all have a nice night.